Try to solve another Leetcode problem. 3363 find the maximum number of fruits collected. So let me directly explain the problem. So according to the drawing, we can see that we're gonna start from 3 positions. It's gonna be the top left, bottom left, and the top right corner. So we're gonna start from those positions. So this is the top left, so this is the top right, and this is the bottom left. And if it is the top left position, it can only go to 3 directions. It can go to right, and it can go to the bottom, or it can go diagonal. So if it is this position, it can go 3 directions, as we can see from here. And similarly, if it is the top left corner, if it is the top right corner, so it can go those 3 directions. It can go to the bottom, go to the right, and go to the left. So this is a little bit different, and we should be clear about it. And for the bottom left corner, it can still go to 3 directions, and it can go up, go to the right, and go to the bottom. So this is a diagonal. This is another diagonal. So if we check it carefully, this is for example, at this position, it is this one, and this one. And similarly for this position, it is this one, and this one. So as we can see that if this is the diagonal line, and this one and this one, it is a mirror. If you check it carefully, so this point is the mirror of this point. So 13 is the mirror of 4 according to this diagonal line, and those 3 directions is also the mirror of here, these 3 directions. So this means maybe we can solve the problem together. If we go from the top right corner, maybe it is similar to the bottom left corner because it is a mirror. If it is a mirror, so definitely we're gonna turn the fruit matrix, and we're gonna solve the problem. We just need to solve one of the problem. We don't need to solve all of them. So for example, we just need to solve this one. If we solved this one, and then we just turn the matrix. After we turn those matrix, so it's going to be the same problem. We can directly use it. So why? So let's just turn this matrix according to this line. So what's going to happen? So this is a 13, and the 14, the mirror going to be here, and the 15 going to be here, and what about this is a 10, and this is 3, the mirror going to be 9, and this 2 going to be 5. So for this 13, it means we can go to 10, 14, and another one. And similarly for this 13, it can go to 10, 14, and another one here. It means it is the same problem. If we turn the matrix according to this diagonal line, it's going to be the same problem. So now we solved the 2 positions. This one, if we solve this position, basically this position it already be solved, and we just need to go to the 3 directions and continue to check. Now we just check what's left behind is about this point. So for this point, we need to go to the bottom right corner, and we have to use n-1 steps. So this means for this point, it cannot go here and go here, because it's going to be more than n-1. If we want to keep n-1 steps, so if it is the top left corner, it should always go diagonally, and then it's going to be n-1 steps, because we need to meet this condition. As we can see, this is easier, and now here, this is also easier. It means we've already solved the problem. So what are we going to do? We're going to prepare an answer. Answer going to be sum of the, let's just use the row I for I row, enumerate the fruits. So this is at the top left corner. It will go directly the diagonal. If it goes diagonally at those positions, it means for this point, if it is the top right corner, it can directly go to this positions. So we don't need to go to this position 1. Because we've already used. Definitely we're gonna use this one. Otherwise we cannot meet the condition of this person at the top left corner. So this means for this position 4, definitely it will use those kind of ways, and it will go to on this 12, it will go to this position instead of a 1. And similarly, after we turn this to 180 degrees, turn it diagonally, and we still need to go from this position to this position. Yeah. Or we can use another way. We can go from this position and go to the up, right, left and right until go to this position, because it's gonna be the same idea. Yeah. Now what are we gonna do? Let's just define a function. We're gonna use DFS. So here I'm gonna call it f. So we're gonna define a function f. I'm gonna prepare I and j. So this is gonna be the starting position. Yeah. Now if we know this function, what are we gonna do? So we're gonna update the answer. It's gonna be f, and we're gonna prepare row and column because it's gonna be the same. So it's gonna be length of the fruit. So here inside, we're gonna start from this position 12. If it is 12, so the row and column be n minus 2, and column gonna be n minus 1. Yeah. So after we use this one, because this is a DFS and we use the cache, we need to clear the cache. This is because if we use the cache, definitely we used the previous calculation. After that, we're gonna transform this matrix according to the diagonal position. Definitely, it means we're gonna turn the matrix, like 13 gonna be here, yeah, 5 gonna be here, and 9 gonna be here. How can we turn it? In Python, we can turn it easily. So we're gonna prepare another fruits array. So the fruits gonna be, we're gonna use a list of the zip and star with fruits. In this operation, basically we turn the matrix according to the diagonal line. Basically, it means a mirror. So 5 gonna be here, and 2 gonna be here. Yeah, everything gonna be turned according to this diagonal line. So after that, we're gonna update the answer. We're gonna still call it n minus 2 and n minus 1 because it's gonna be the same. So here we didn't prepare another function, we just use the same function. So this is according to the design of the problem. So they designed and let you to just use this method twice after turn this matrix. Finally, we're gonna return the answer. Yeah, now the difficult part is how to write this function. So this is normally this is gonna be easier. We just need to check from this position 12 until go to this position 4. Yeah, so let's just check the edge cases first. So if let's check j first. J is the column. So if j equal to n, we're gonna return false. Or another one, if I equal to 0. Yeah, I just write like this because this is easier to check. Although it is a little bit slow, but it's easier to write. So if I equal to 0 and j not equal to n minus 1, definitely we're gonna return negative infinity. So this means from this position 12, if it goes to this position 3, definitely this is not we are calculating. We are calculating for this position 4. So if it is not equal to n minus 1, definitely we're gonna return negative infinity. Or if j equal to n, it means go out of the boundary, we still return negative infinity. Otherwise, we're gonna check I. So if I equal to 0, so this means if I equal to 0, this means j must equal to n minus 1. Because here is j not equal to n minus 1. And for here, it must be j equal to n minus 1. Yeah. So we're going to return a value of this grid, x. So this x is going to be the fruits of I and j. Yeah. So finally, we're going to return the maximum path. So the maximum path is going to be the maximum of f. It's going to be I minus 1. The top line, it's going to be I minus 1 with j. Let's just use maybe j plus 1. And fi minus 1. And j. Yeah, and I and j. And the last one going to be fi minus 1 and j minus 1. So definitely it means those three positions from this 12. So this is I, and this is I minus 1 with j, and this is I minus 1 with j minus 1, and this is I minus 1 with j plus 1. And we're going to choose the maximum of those three values plus the previous value, our current value x. So this is going to be the final result. Yeah, so this is going to be the entire code. As you can see, there's not so much coding. Let me just run it and submit it to check if it works. As you can see, it works, and I think the speed is okay because we used DFS with this I and j, and this I and j gonna be, yeah, like 1000 times 1000. So the time complexity gonna be n squared. N is the length of the matrix. Yeah, I think that's all about it. Thanks for watching. See you next time.